Welcome to the Engineering 2210 Materials Project Team Sapphire for Spring 2021. I am Adam Rice.
I am Dalton Phillips.
I'm Lucas Silva.
And I'm Jacob Williams.
So the background and motivation behind choosing sapphire as a material, I had seen industrial diamonds in use, and then I found out that you can grow them. Thought that was kind of cool, but then I found out sapphire is just as big, if not bigger, than growing diamonds. And it just kind of sparked my imagination, where I was wondering, okay, I heard about the iPhone and Gorilla Glass versus sapphire glass, and on watch faces you have like the really high-end watches, you have this sapphire glass that's being used. And so I wanted to know more about it. In the process, we discovered that there are many more applications than the two or three that the public seems to know about, which is gems and some glass, high-end glass. So we're going to start with the processing technique here. The processing technique is called the cryopoulos method, which was pioneered by Spyro Kapoulos in 1926. And he was originally trying to do it as a direct crystallization of a melt. And what you do is you initiate the growth to the seed crystal, and you attach it to the top end of a vertical water cooling rod. It's lowered into the melt, and the furnace temperature is slowly cooled to encourage the downward growth of the crystal. Thermal gradient controls the process, so the only crystal layer at the solid liquid interface remains molten. The essence of this method consists of growing crystals with an unusual, sharply convex shape of the crystallization front under conditions of low temperature gradients in the hot zone. So the crystals are normally boules, and they can get big. The biggest crystal boule that they've ever made is about 220 kilograms. There's actually a picture of it in the background on the bottom in the middle. That's the 220 kilogram record boule that was made.
Awesome. Thank you for that, Adam. So now we're going to talk about some of the applications of sapphire. To start out, sapphire is the base material for LED production. Sapphire is made for LEDs. LEDs are used to backlight consumer electronics such as TVs, computers, and tablets. Sapphire is also used as a substrate for semiconductor circuits. Sapphire is used as a substrate in the production of large diameter wafers that are used in radio frequency integrated circuits. Besides its excellent electrical insulating properties, sapphire has high thermal conductivity. Sapphire is ideal material for optical applications. Sapphire is one of the hardest minerals. Because of this, its structural strength is extremely high. Optical components out of sapphire can be made much thinner with better transmittance as well. Sapphire is widely used in medical devices, accurate machine, and industrial applications. Sapphire bearings are precision miniature components typically used in instruments, meters, control devices, precision mechanisms where low friction, long life, and dimensional accuracy are considered. And sapphire is also used to make glass. You can see sapphire glass used in homes and other buildings. This glass is thinner and much stronger than typical traditional glass.
I'll now explain one application of the sapphire. So no industry requires a more reliable and durable material than the military. So it's no wonder sapphire is going to be used in the military. Sapphire maintains its characteristics when under high pressure, high heat, acidity, high impact, and pretty much everything else you can imagine. This makes sapphire ideal for vital optics and lasers, anything that like the military will use. So we went more with the optical side of the application. So these are used on like viewing windows on equipment. They're also used for submarine applications because of their high resistance to things.
There are many countries all around the globe that produce, manufacture, and sell sapphire products, such as Rubicon Technologies, based off of Chicago, Illinois. They produce optical windows for lenses and sensory devices for military equipment and transparent armor. They also make super thin polished wafers for electronic devices. And there's also Schott AG, based off of Germany. They supply super thin, super durable glass. They also produce computer chip wafers as well. There is the same Gobain, based off of France. They produce transparent armor, opto mechanical windows, semiconductor manufacturing, and other industrial purposes. There is Precision Sapphire Technologies, based off of Lithuania. They deal with polished synthetic sapphire windows and wafers, synthetic ingots and blanks. They make homegrown sapphire tubes and microtubes. They also grow sapphire rods. There's Crystal Wise Technology in Taiwan. They produce semiconductor, OLED electronics, optical fiber communication wire, and wireless communication devices as well. There is also this Surmet Corporation, based off of Burlington, Maryland. They produce optical transparent windows that can be penetrated by ultraviolet rays. They also produce different thicknesses and sizes for the products. There is also a company called Kyocera, based off of Japan, that produce sapphire cells, sapphire LED, electronic devices, handling arms, windows, glass plates, wafers, lift pins, plasma generation tubes, and other scientific devices.
This was the materials poster project from Team Sapphire. We thank you for watching the video and listening to our discussion about the material Sapphire.